Okay guys, today we're going to explore a new version of differentiation, and we're going to explore product rule. So if you had some sort of function, let's say you had some sort of function like g of x, okay, and you wanted to find out the derivative of something of two functions being multiplied together, let's say, okay, yeah, let's say this. Well, you know how to do these individually, but how would you find a derivative for something like this? Well, and this is where product rule comes in handy, because we can differentiate basically products of functions and find its corresponding derivative. So I'll first basically write the derivative of this, and then I'll go backwards and show you the symbolic form of this and how it basically is derived. So let's say I have g of x, okay? And this is, and we had, 5x cosine x. So basically what we do is the okay. Let's say that f of x is equal to 5x and t of x is equal to cosine, let's just have that be cosine x. And basically, this is important to mark them like this so that you can follow my, basically how I derive it, because I will derive this in a second. Basically what you do is dx of g of x equals, so we'll say it will be equal to f prime of x times t of x plus t prime of x times f of x. Okay, so what is this saying? This says that if we want to take the derivative of a function g of x, which we said was up here, it's equivalent of taking the derivative of f of x, which we said was 5x, times t of x. I know this looks like a plus sign, that's my bad, probably shouldn't have picked t. And then you would take the derivative of t of x, which is the derivative of the cosine, and multiply that by f of x, and that would give us basically our derivative g of x. So let's test out this theory, and yeah, so let's test it out, and we'll see, I might prove it with an integral to show it that this is the derivative. So basically the ddx of g of x is equal to, well, we take the derivative of the first one, which is 5x. The derivative of 5x is 5, and we multiply that by the second function, t of x, which is cosine x, and then we add the derivative of the second. The derivative of the cosine is the negative sign of x, and with that we then just write the second function. Okay, so basically our derivative is 5 cosine x plus negative 5x sine x. This is our derivative. Now, if, let's say, one second. Okay. Yeah. So, yeah, okay. Yeah, we won't do that then. So, yeah, this would be the corresponding derivative for this function. I could prove that this is the one by integrating it, with integration methods, and I will get back to g of x, but I think I'll save that for a later video so that I don't overwhelm you. So basically, I'll rewrite the product rule one last time. So let's say we have g of x, and I'll write this out quick and then I'll show you on the camera. G of x is f of x, and, well, actually, it's probably better if I just say this. Let's say we have an h of x, and this is this times this, okay? So what is this saying? This is saying we have a function h of x, and that's equal to the multiplication of two other functions, and that the derivative with respect to x of hx has to equal the derivative of the first multiplier, f prime of x, times g of x, just the function g of x, and then plus g prime of x, so the derivative of g of x, and then times just f of x. So this is the symbolic representation. The idea is that the derivative of a function h of x, where h of x is equal to a product of two functions, that this is equal to the derivative of the first function times the second function plus the derivative of the second function times the first function. And this is okay. Yeah, so yeah, that's basically how that works. So yeah, this is basically the idea of chain rule, product rule. And yeah, so that will be the end of this video, and like it and comment on it.